Hi, my name is Pradeep Dhaliwal. Welcome to this MCAT Science Review video on the topic of molecular orbitals. You're going to start off learning about bonding orbitals, and then you're going to learn about a few different kinds of bonds. After watching this video, you should be able to explain how molecular orbitals combine to form different bonds of varying strengths. And you'll learn to answer questions such as, which of the following atoms would have the shortest carbon-carbon bond? Bonding orbitals are the orbitals that form when two atoms' atomic orbitals combine. Let's see what happens when these two s orbitals approach one another. You'll notice that they're both the same color, which in this case means that their electron waves are in phase. So as they approach one another, they'll combine to form a bonding orbital. This bond stabilizes those two positive nuclei, which normally wouldn't want to be so close to one another. But what if one of those electron waves were out of phase? In that case, the orbitals would combine to form an antibonding orbital. By putting those two negative charges closer to one another without actually having them combine, this bond is less stable than the normal conformation and will eventually force those atoms apart. You should also know what happens when we add p orbitals into the mix. First, let's look at an s orbital being combined with a p orbital. You'll notice that one lobe of the orbital is in phase, while the other is out of phase, so that when these two combine, they'll form one bonding orbital and one antibonding orbital. And the bonding orbital is where both of the electrons from this bond are actually going to be found. If you've got two p orbitals, in this case you've got two out-of-phase lobes. So as you might guess, this creates two antibonding orbitals along with one bonding orbital, which is again where all of the electrons from this bond are going to be found. Understanding the structure of bonding orbitals becomes important when we actually look at the structure of various bonds. And in this case, they're going to be ordered from weakest to strongest, with the single bond drawn above placing somewhere in the middle. And all single bonds are the same type of bond, referred to as a sigma bond. Understanding orbitals becomes important when we look at double and triple bonds, because even though these bonding and antibonding orbitals were created by one p orbital from each of these atoms, each of them still has two more p orbitals. That's important because the electrons in adjacent non-bonding p orbitals can form associations with one another in order to create double bonds, which are stronger than single bonds. These p orbital to p orbital interactions are known as pi bonds, and by themselves they're actually weaker than sigma bonds. So in terms of strength, a double bond is really something more like 1.5. Another important thing to note is that this extra pull means that double bonds are squished shorter than single bonds. And those leftover p orbitals can do exactly the same thing to form a triple bond, even stronger than a double bond, and even shorter. So a triple bond is just 1 sigma and 2 pi's. Now that we're nearing the end of the video, let's come back to that question from the beginning. And we're going to solve it by listing the strongest carbon-carbon bond in each of these molecules, which is single, triple, double, and double. And as you should remember, the stronger a bond is, the shorter it is. So the correct answer is B, propine. To see if you're ready for test day, you should be able to fill in this chart and order the terms at the bottom of the slide from weakest to strongest. Two in-phase orbitals form a bonding orbital, whereas two out-of-phase orbitals form an antibonding orbital. A bonding orbital and two non-bonding p orbitals form a sigma bond and a pi bond, whereas a bonding orbital and four non-bonding p orbitals form a sigma bond and two pi bonds. If you want to order these terms at the bottom of the slide, they go pi bond, sigma bond, and single bond, which are two terms to describe the same thing, then double bond, and finally triple bond. As long as you can remember all of the information on this slide, you should be in a great place for any questions about bonding that you might come across on test day. Congratulations, you've reached the end of this video. Now you should feel comfortable with all of the information that you just heard about molecular orbitals. If there's any part of it you're still confused about, feel free to go back and rewatch the video. Best of luck on your MCAT.